hearing a story about, you've probably got your morning coffee and your dog and you're going for a walk and you're watching a mighty force of nature actually transform around you. It's powerful and powerlessness all at once.
No, absolutely. It's that feeling of what you say, it's powerful and you feel powerless. Because physically there's really nothing you can do. You're there, you're just looking at it. It's like watching your house burn.
Welcome to Wonder, the Planet Earth podcast for the curious. You're joined by Earth scientists Dr. Anthony Reid across the table. Holly, I'm right here. And our guest today, we actually have to cross live to the Arctic to meet her. So today we talk to Hedda Anderson, glaciologist, expedition lead, and someone who actually wakes up in the morning, looks out her window and sees a warming world and really sees that. Anthony and I spend a lot of time talking to Hedda what it means to inhabit these icy landscapes and live within a frozen world that is changing. I'm really looking forward to the conversation. Anthony, I'll hand it over to you.
Thanks, Holly. Great to be here. It's so wonderful to have you here, Hedda. Thank you so much for your time. You've written something along the lines of, to understand nature, you have to be in nature. It's such a beautiful statement. And I believe that you have an even more powerful kind of word for this that you are, which tries to express that connection.
Yeah. It's not my word by any means, but it's something that I live by already. And I think when I learned that word working in Greenland last summer, which is Sila, which literally means in Inuit that you human being, you are a part of nature as well. And that nature is as much alive and has as much right to life as we have. And it's, I think that's just a key point, because I think so many people are extremely disconnected from nature and what's going on with nature. And that just really resonates with, how I live my life, I guess.
Definitely. And being outside so much and being a guide and a glaciologist on Svalbard, it's hard to imagine a more different lifestyle than a sort of a southern hemisphere,
correct,
hot and dry Adelaide summer.
It's 35 degrees here today. It's hard to picture the field work that you were just in. And as Anthony mentioned, you do live in Svalbard, which is the northernmost place where there is a human settlement. I can't quite imagine the beauty and the immersion you must feel in that landscape. How do you, when we talk about this word Sila, how does that feel when you wake up in such a different location for me and Anthony at least? How do you feel that?
It's just when you wake up, it's quiet. And you are surrounded by, nature that is so mighty and powerful, and it speaks to you in a way that, really lets you know that you are the visitor here, you are the humble guest. And it's just, I woke up in my tent yesterday and I just opened up, and we've had pretty horrible weather the last few days out, and it was finally clear skies, and we have, the return of the sun now.
Of course.
And I saw the sun for the first time since December yesterday.
Of course.
So that was cool.
The long night of winter.
Yeah. And just to wake up and open, if it's your door or your tent door, and see that just really it takes your breath away, really does. I don't think you find that in many places in this world today. So it's a real privilege to get that, to experience that.
What came first for you? Was it this feeling of deep, not only just deep connection of nature, but really being of nature? Is that what sort of pushed you towards glaciology, or is this a feeling that you've learned through the years?
I started studying geology when I was in my early 20s for an undergraduate, and it was kind of a random choice because I had no idea what I wanted to do really, but I knew I wanted something in natural sciences and something to do with being outdoors. And I was blown away by, learning about our planet and how it's all put together, and the rocks, and, the dynamics of how our planet is shaped. It's just incredible, right? And then moving along, I did something completely different for the rest of my 20s. I worked in skydiving for I had a need for some adrenaline, I guess.
Clearly.
Yeah.
Oh my gosh.
We don't need to talk a lot about that. But then I turned 30 and I was kind of like, you know what? I've had fun, but I do really want to, go back to the beginning again and go back to earth sciences. So I started completing my bachelor's degree at the age of 30. And I did that. And then simultaneously, I moved up here to Svalbard. And I started my life here and spending a lot of time out in field work with the university. And by spending time out here, like consecutive years, and it didn't take long, it was maybe a year and a half. And I was out walking my dog one morning, and we have two glaciers kind of sitting at the south end of Longyearbyen, which is where I live. Mm-hmm. And these are two teeny tiny valley glaciers, and they have moraines or forefields, which are very much ice cored. Mm-hmm. And I was walking my dogs on a morning hike I like to do. It's just a local mountain in the backyard here. And you have to hike one of the moraines. And I was looking at it and I was kind of like, oh, something's changed.
Wow.
Because it had literally collapsed the entire thing where the path used to go. And I was kind of like, where do I go now?
Mm-hmm. How
because
visceral.
It had melted out. Mm. And that just really like opened my mind to like, oh my God, this is changing so fast. Like if I can see it right next to my house, one day to another in this short time period, then, you already know something's going on here, but you don't know how much it is. So then I decided that, okay, I need to understand more of this. Mm. So it's just that connection that I wanted to understand the environment that I love so much more really and understand what impacts it.
Well, that reminds me of a breathtaking quote of yours that I found. I actually want to get this right. On this topic of Sila and change and impermanence and balance, you've written that, glaciers here reflect the rhythms of Sila, teaching resilience and patience to those who live alongside them. They teach us about the interconnectedness of all things in the natural world and about the fragile balance that must be maintained. And I think hearing a story about, you've probably got your morning coffee and your dog and you're going for a walk and you're watching a mighty force of nature actually transform around you. It's powerful and powerlessness all at once.
Yeah, no, absolutely. It's that feeling of what you say, it's powerful and you feel powerless. Because physically there's really nothing you can do. You're there, you're just looking at it. It's like watching your house burn.
Yeah.
And that's just a very, very powerful feeling. And, glaciers, they are very much living things, I would say. They're not just dead blocks of ice. They have a purpose in nature very much, and they regulate the climate globally. And to help people see that, it's so important. And also to understand how important they are, not just, on a global perspective, but also for local communities, whether it be here or Greenland, especially because there they have the indigenous population that, has lived amongst nature for longer than any one of us. And they are experiencing an incredible change of their environment. And I think it's important to address that too, because it's changing people's lives.
So how have you gone about this? Seeing it on the scale of 1 year is obviously very powerful, but you've actually been working to try and document and understand this at a much longer, or at a longer time scale, to really cement that concept of things are changing. What sort of things have you been doing?
Well, I've been working with mainly just kind of documenting changes. Yeah. I have done lots of field work up here with the university. However, I found that the way I work is that I work best if I am part of research and not part of research, because it allows me so much more freedom. Simply put, to do what I want to do and how I want to do things, and of course in accordance with scientific principles and ethic principles of science. And so I've basically, together with my research group called the Living Ice Project, we have for many years now done a lot of drone surveys and a lot of drone imagery of glaciers, particularly on Svalbard, but also in Greenland and mainland Norway and Sweden, and also now in Antarctica as well. And basically what we do is that we take pictures of glaciers. And we do it with a drone. We do something called spherical imagery, which means that we just fly the drone up. It's so simple, like anyone can do it. It's almost embarrassing to call it research. But it's so easy. It's like so much value for how much it takes effort-wise. And you fly a drone up, you push a button that's automated, and then it just takes pictures in all directions, and then it stitches together to a 360-degree image. And to do that, then you come back to the same glaciers annually or inter-annually, however, whenever you have access to them, really, because access to glaciers is a huge thing.
Oh, sure.
Because they tend to be quite remote. And then you retake the same picture from the same spot if you can. And then you will qualitatively be able to see differences. And that's mainly used as a classroom tool, as a general public tool, because you can't really quantify change. You can kind of qualify change. And that's something that's very powerful. And then we also do historical rephotography. So we find pictures that are, 100 years old or 150 years old. And then we go to the same spot, and then we try to find the exact same frame. And then we retake that picture. And then you can just kind of sliding curtain toggle between those two. And that's an incredibly powerful way of showing the changes that are going on. And of course, we are 4 researchers, and we are working on developing our project. So moving forward, we will do more frontal mapping of glaciers as well. So we will do structure from motion, which is basically just a series of images. It doesn't have to be very complicated, but you do have to take a bunch of images in a series, and then you can construct an elevation model from that. And if you do that from year to year, then you can actually quantify changes.
I see. For how much? So, and where are we looking at change in the sense of ice carving off the front of the glacier, or are there other ways that the glaciers will change?
Glaciers change in many ways, and they are it's kind of sad, but also kind of interesting that we like the living thing is just because they change, they move, they are incredibly dynamic, and that also applies to how they're losing ice in a way. They are very living in the way that they do that. You can have frontal calving, front retreat. Calving will typically only happen on glaciers that are in where the front is in the tide, in the water, in the ocean. Right. Whereas retreat of the front is typical for land-based glaciers, or glaciers that has been in water, but then they have retreated up on land. And they are like mainly the marine glaciers, that's what we call them, or tidewater glaciers. Those are the big boy glaciers that you have around the world. That's where the front is being pushed into the ocean in some fjord or bay somewhere. And then the main control on losing ice is calving at the front. But if you look at the small valley glaciers, or the land terminating glaciers, then surface melt is the main parameter that causes ice loss.
Amazing.
Yeah.
And surface melt, do you mean from the top of the glacier itself?
Yeah.
So I've read something
Absolutely.
So I've read something about if in places where you have these days, you have extra dust in the atmosphere, dust or even ash can settle on top of the glacier and decreases the albedo and increases its capacity to melt. Is that type of thing that you're also witnessing?
Yeah, absolutely. It might not be, well, Svalbard is full of dust. It's a known thing here that literally like everything here is covered in like a fine layer of sediments, and it's a side story, but we do have a lot of reindeer up here, wild reindeer. We have around 20,000 animals up here that live out here, and the way they die is kind of horrible because they eat grass or vegetation here, whatever it is to eat up here that's this big. We don't, moss like in but very sparse vegetation up here. But anyway, because of all the wind-blown sediments, Ionian sediment. Is that what it's called?
Yes. Yeah.
Oh, I got it right. They settle on everything up here, and that includes the vegetation. So when reindeers, they live their life here, and their life evolves around eating because there's not much to eat here. And that means that their teeth actually get grinded down by those sediments that are being transported here. So most reindeer here die of starvation. And if you find a skull from an old reindeer, there's like no teeth left in them. It's kind of horrible, but it goes to show how much sediments that are being transported here. But on glaciers, yes, that can happen. But I think like when we look at lowering the albedo, reflectance ability on a glacier, a big problem is also algae, snow and ice algae.
So does the algae
create something?
Sorry.
Yeah. No. Sorry. Ask the question.
We're so surprised to hear the word algae.
Questions.
Yeah.
The algae, does it live just below the surface in the layers of the ice, or just beneath the snow as it's forming? Is that where it lives?
Well, it can live in all places, basically, where there's any access to water and heat from the sun, basically. And what happens is that when you have some sort of like colony of bacteria that start to form, and we see this also in Antarctica, actually, it's been researched quite a lot there too, is that once it starts to settle on the glacier, it'll live like right on the surface, typically, of the ice when you have blue ice or blank ice. And then it'll form in these little colonies, and they are like little spots. They can be this big, they can be that big, they can be huge, they can be small. And what happens is very interesting because they absorb more energy from the sun than blank ice. So it melts down into the glacier, and it turns the glacier into kind of this Swiss cheese looking thing.
Gosh.
And kind of destroys the crust on the glacier. So that's ice algae, and they can typically be black or red algae. And then you can also have snow algae, which then can actually survive below the surface of a new snowpack. And then that works its magic in there.
Unbelievable. Yeah. It's such a living thing. Another thing that I think of when I picture glaciers is photographs of you and people like you crawling your way through incredible kind of chasms or like caves almost in the ice. Is this the more openings or spaces in the glacial system, the more melt is able to occur? Is that a part of it?
Not necessarily. I think that what we do here is kind of nuts, I guess, to the rest of the world.
Correct. Just in my reaction, I was just like, what do you mean?
Climbing inside a glacier.
Oh, gosh.
Yeah. And it's really cool, actually, that we have that access to glaciers here in winter only, because in summer, those tunnels, they are full of meltwater. So it turns into, a theme park, a water theme park, if you go there. So you don't want to go there. But in winter, everything freezes, and typically we will enter meltwater. But in winter, everything freezes, and typically we will enter meltwater channels that are frozen over. And then, meltwater channels, they are, the veins of drainage of meltwater within the glacier. And they are lateral. So if you have a glacier sitting like that, they'll be on the edges of the glacier. And then some of them will go deep into the glacier and come out at the front of the glacier somewhere, and then you can access it either from the top, so you find an open channel, and then you kind of just wiggle your way down there, and then we have one crazy scientist, he was one of my teachers when I was doing my glaciology masters. He mapped an entire meltwater channel from the top of the glacier to the bottom. He crawled through the entire thing.
That is brave.
He's made of something different than I am.
That's right.
But we do access them, and we can spend time inside them and look around. And what's really interesting is that we use, for tourism up here, we actually use them on the local glacier just behind me here. And because of that, I've been inside that ice cave or that meltwater channel for so many years, every year now, and you see it change so much from one year to another. We go to the last known point, and then we just kind of dig a hole in a snow bridge that's typically formed, and then we kind of look down a gaping hole, and then we're like, okay, let's just rappel down here. And then we just wander around inside the glacier until we find a collapsed snow bridge or something we can crawl out of. And then it changes so much from year to year. It's really astonishing. And it really tells us so much about how the glacier is responding to climate up here as well.
So that was my next question, actually, climate. So the reason that the glaciers are decreasing in size is because they're not being replenished quick enough for the melt, right? The simple reason.
No, sorry, please continue.
Oh, no, I was just saying the simple reason is there's not enough material, snow and ice forming on the glacier to keep pace with the melt that is happening either at the front or underneath.
Well, technically there is enough snow.
Is that right?
There's more snow now than there has been in the past because of the climate warming. It's getting milder and we get a lot more precipitation now.
A lot much
snow.
more complicated than you think. Oh my God, this is absolutely fantastic. So in Svalbard, you're actually seeing an increase in precipitation in the form of snow in the last sort of couple of decades, and rain as well, right? Yeah.
Yeah, absolutely.
And yet the glaciers...
It rained yesterday.
Wow. And yet the glaciers are shrinking. So how? So
it's kind of a paradox.
So then before maybe we get in the nitty-gritty of the paradox, because I actually just think I was talking to you about this earlier, Anthony, like how complicated a climate system is. It's tremendously complicated, cause and effect. Like, once we accept that we have a planet that's warming, the cause and effect of weather events versus glacial shrink and all of these things, it's messy. I wanted to ask you about timescales. I don't know about you, Anthony. I'm really I love thinking about the different timescales you can look at when you look at different parts of our planet. And it's funny because you described that there's you were walking your dog one day and all of a sudden sort of this part of your local glacier had collapsed. But I don't imagine that that's a glacier that could equally be formed in that quicker time as it takes to disappear. So do you find yourself thinking about the different timescales that are encoded in a glacier and particularly the one that you're watching them shrink on?
It's kind of like, let's say you do a job, you want to build a house. Let's use a house metaphor again. And you spend, so many years of your life building this house brick for brick, with your timber and, you design it, you put it together, you put your life into it. Some people do that, they spend their entire life on a house, basically. Mm-hmm. So let's imagine that that's the analogy for a glacier. And then, again, let's say a fire happens and it burns it down in a day or less. And that's kind of what's going on with the glaciers. And that's, you mentioned that you're just kind of a bystander on witnessing that. And then, standing here out by the glaciers and looking at them and then touching them and physically being near them. And you think, you hold a piece of ice in your hand and you're like, maybe this is like 5,000 years old. And then we've spent, 150 years melting it away, give or take.
I like
maybe
that.
Not even.
I like that house analogy because, not to get on my soapbox, but it is sort of within that ice is geological history is encoded in that ice. There's information about past climates, there's past weather, past life, past events on the earth. And it took the earth a long time to build that archive of what it's been. And to think that we are in one way or another diminishing that archive and creating what will be problems for ourselves is quite a sobering thought. I do want to return back to the messy dynamics though of why that glacier is shrinking. These glaciers are shrinking despite the fact that they have the food to keep growing in snow. So why are they shrinking? Literally why?
It's just because even though we're seeing a lot of snowfall now, generally on average it's increasing. It's just not cold enough for all of that snow to be sustained into a new melt season. It goes. It doesn't stay because you'd think that summer temperatures are the biggest problem, and to a degree it is because that leads to a lot of surface melt. Like the sun is 24 hours going in a circle. It's above 20 degrees several times up here in the summer, which is absolutely insane. And it just melts away. everything that's on the surface of a glacier. So it kind of just, we see that on really warm summers, that the snow layers, because a glacier, typically you have in winter, the entire glacier is snow covered, and then spring comes, and then summer comes, and then that snowpack will retreat up to the accumulation area, the higher elevated part of the glacier. And that's the part you want to keep and feed, right? That's kind of where you put the food in on a glacier, and then it grows, technically. But then what we see is that because of the extreme summer temperatures and the general average warm temperature annually, the snowpack is also retreating now. It's not, as big and as thick as it used to be. And then on some glaciers now, it's just completely gone. There's no more accumulation area left. It's just their ice. And that's really disastrous for glaciers, because then they lose that part that actually gives them a positive mass balance, or have the opportunity to give them one. It kind of removes the food from their hands, so to speak. And then you have actually, like I said earlier, summer climate change, it's getting warmer, but winter climate change is actually the huge problem here, because right now, it's 25th of February today, and it's 0 degrees outside in Svalbard. It's kind of raining right now. And it's if you look at the average, let's say take a 5-year interval, let's say 1975 to 1980, and then we take 2020 to 2025, it's on average 8 degrees warmer in January now than it was back then.
Far out.
That's a lot.
So,
wow.
Yeah, it is. So that's what we're seeing. And then kind of that's the air temperature, and the air temperature is very much a project of what's going on in the ocean, and the ocean temperature and the sea ice coverage, which is kind of the joke in everything here. So it's very interconnected with what's going on in the ocean here, because Svalbard is surrounded by ocean. So yeah, it's very much connected to that.
Yeah, there's that interconnectedness. Can you walk me through? Because I don't know too much about these feedbacks here, but one thing I think I understand about global warming is that the oceans absorb a lot of that heat. So is it, with heat, the air temperature being 8 degrees above average versus the oceans warming, what's inputting what here? What's influencing what here?
Well, I'd say the main concern, the kind of main part of the equation, is the ocean temperature, and that is due to a general global rise in ocean temperature and ocean currents, because you have the North Atlantic current, which is a very big, strong surface current that comes up towards the Arctic, kind of goes across the coast of Norway, parallel to Norway, and then it comes up here in the Arctic. And it splits it forks out in a Y, and then it goes to the east side of Spitsbergen or Svalbard, and then it goes to the west side. The east side, then it goes into the Barents Sea, and the west side, it goes up through something known as the Fram Straits. So it's the West Spitsbergen current, and then it's the East Spitsbergen current. And this is a mass transport of hot water that comes from mid-latitudes. And when that comes up here in great vast amounts close to the surface, it spills into our fjords. It's near the surface, near Svalbard, so that leads to increased evaporation. It leads to more humidity. It leads to more weather, more extreme weather. 2 weeks ago, we had class 2 hurricane wind speed event here. Yeah, I was trapped at work. I couldn't go anywhere.
Gosh, that's not normal for you to have hurricanes in Svalbard?
I mean, it's in the Arctic, and rough weather is to be expected up here.
Yeah.
But we are seeing much more frequent big storm systems coming in, and it's really shaking the ground here for everyone that gets to stay here and experience that at that time. And it's so yeah. Back to that question, it's just that main part is generally what's going on in the ocean. And like you said, Anthony, I think you said that, or was it, I can't remember which one you said that, but that the ocean absorbs most of the excess heat. And that's the main thing. That's why. Because there's so much more excess heat in the atmosphere than it used to be because of burning of fossil fuels and then trapping of heat inside our atmosphere. And then that heat, in actually 90% of the excess heat produced by human burning fossil fuels has been absorbed by the ocean.
Oh.
So the ocean has been taking away so much of that excess heat. And then there's two things to think about. One, at what point will the ocean be saturated? At what point will it start to tip over and no longer be able to dig away at that excess heat? And then what will that do to the temperature in our atmosphere? And then the second thing is that, the warmer it gets in the south, you can double that by 10 times up here. Or in the south, because of heat transport in the water. And that is really what is the main factor of changing climate in polar regions, both in the north and the south.
Before we come back to these ocean circulations, because this is fascinating, like the ocean as this powerful dynamic force, like in our human capacity, it's a regulatory force. But firstly, to our listeners, if it's in case it's not been made obvious, this idea of the global warming is felt much more so at our polar regions for a variety of reasons. So, sitting here in Adelaide, global mean temperatures rising means one thing for us here. It means one thing for people in New Zealand, another thing for the polar regions again. But Anthony, this ocean circulation, I feel like we actually kind of started talking about this in our last episode with the South Sandwich Islands, and actually how a change in ocean circulation brought into fruition the capped planet we know today.
The formation of the Antarctic ice caps was largely driven in part by the opening of Drake's Passage in the Scotia Sea and the formation of the Antarctic circumpolar current. Yes. And Hedda is obviously at the other end of the planet than to the circumpolar current. But you do have experience in Antarctica as well, and the South and the Scotia Sea as well, Hedda. Is that right?
Yeah, absolutely. I typically go towards Antarctica for work and also the Scotia Sea once a year.
Gosh.
So I live up here, but I'm not a fan of staying here necessarily all throughout the 4 months of no sun. And also I do have a job that affords me the opportunity to go work in Antarctica, to do the same job there as I do here.
Yes.
The topic is Antarctica instead of the Arctic.
Yeah.
And then,
but you're also seeing the same. So you're seeing your glaciers melt at the very local scale, right at the back of your house almost here. Then you're looking at the other glacial systems on Svalbard itself. You've been over to the Greenland. You've seen the glaciers there. You've talked with Inuit people who live that experience. And you're also now experiencing and witnessing this firsthand in Antarctica as well.
In Antarctica, everything is bigger, right? It's difficult to measure on a small scale what's going on in Antarctica, as I feel like we can do more here.
I see.
Because here we have more resources to do so. We have a settlement, we have a university, whereas Antarctica is by researchers visited, that if you got a nice big grant and you can go do some field work in Antarctica. But can you imagine, how much it actually takes to do field work there on glaciers? So that's why I've kind of, through my work in the tourist industry, have really pushed for research being a part of the tourist industry in Antarctica as much as up here. And then, of course, we see a lot of changes, and it's just, I would say, like the place that I feel like changes the most. I don't know how to say it in English. Like you can touch it the most, it's one of those things that are really obvious if you look at it. It's in South Georgia. It's an island, a subantarctic island. It's where Shackleton is buried, Ernest Shackleton. That's where he made his way after the Endurance failure in the Weddell Sea for rescue. And this place is such a laboratory for climate change on glaciers and wildlife. And it's I call it Jurassic Park, this place. because it's so much wildlife there.
Yeah.
You rock up on the beach with your little boat, and it's just like seals everywhere on the beach. The soundscape is just absolutely bonkers.
Well,
and then you have, hundreds and thousands of penguins, in the background of that. And it's just, it's so wild and it's so remote. And it's just, when you discover it for the first time, you're kind of like, wow, this is Jurassic Park.
Yeah.
But the thing about South Georgia is that you have a lot of glaciers there too. So I actually have almost like close to half of the island now is covered in glaciers. And much like, Svalbard is kind of in that same position, an island or an archipelago surrounded by ocean currents and a lot of upwellings and like very dynamic place. So it's very similar to Svalbard in many ways. And there we also see that massive retreat of glaciers from the 50s until now. And there it's had such a surprising effect on the wildlife, because there the warming ocean has led to higher temperatures, which has led to glacier retreat, which then has led to more space for instance, king penguins to populate. So the island is being filled.
At least the penguins are happy
now. Yeah, exactly. So it's kind of like the more the glaciers retreat, the more penguin real estate you get.
Wow.
So it's one of those things that it just shows you how dynamic and alive our planet is, and how one thing relies so much on another. Because now we're talking about a 50 to 100-year scale where the Antarctic fur seal, which is a very popular seal in that area, was almost extinct because of hunting, and now it's overcrowded. Wow. It's too many of them. So it's just, it's really interesting to see what's going on in the south as well.
Mm-hmm. Isn't there a tremendous amount of beauty in basically taking all of this complexity and just like understanding, the richness of what it is? I mean, there's a fairly devastating overtone to listening to how visceral this glacial retreat is, to academically understand we have a warming planet, but then to hear your story about watching this ice fall apart in front of you. That's a gut kicker. That's pretty phenomenal. I do think it's hilarious that on a lighter note, I do think it's hilarious that the penguins have made a comeback, because what Anthony and I did on our previous episode is actually go roaming on Google Earth, and I think I picked a spot. And you're right, you dump into it, and there's just thousands on thousands of penguins. So you have to find you have to find lightness lightness and wonder in our wonderfully intricate Earth system. And you can only hope that being in nature as you are, Hedda, helps you feel deeply appreciative of the conditions within which humankind has learned to live and how fragile those conditions are. Absolutely. Yeah. No, it's my main, how do you say, my main message? What I work for is to share that try to share that feeling with others, that, tourism is here to stay. It's not going anywhere. It is expanding. That's another discussion. But I can choose to be a part of it and try to, make it better, or I can ignore it and just be a grumpy scientist that hates tourists.
Wow, this has been,
because there's a lot of those.
Yeah,
absolutely. Yeah, intruding on our Antarctic pristine research stations. Fantastic, Hedda. I think this has just been an absolute huge eye opener for us down here in the southern continent. It's one thing to hear about temperatures rising in the ocean, but it's another thing to witness glaciers melting. So thank you so much for sharing that with us. I really appreciate your time. Thank you.
Yeah, of course.
Thank you.
Thank you for having me.
Thank you.